Okay, any questions at all? I know if you had a question, I'll answer that later. Any questions on the immediate last problem? All right. The next one, what was that? Was that C or? Oh, that was E. Okay, so F. Let's say you need to solve the inequality x times x plus 2 times x minus 3 larger than 0. So let's say you need to solve this inequality. That is, for what values of x is this inequality true? For what values of x is this inequality true? So how do you solve this? Go ahead. Say it again. You mean multiply out? No, if you multiply out, that's not going to help. You mean multiply x times x plus 2, right? X squared plus 2x.
Multiply x to the power.
Yeah, so that's not going to work yet.
Set each of them equal to 0, or set each of them greater than 0.
Okay, so first of all, you have 3 factors here, right? And there are a couple of different ways of doing it. I think one of the ways that you might have seen before is to make a sign graph of each factor, right? So you have 3 factors. When is the product positive? Well, when all of them are positive, the product will be positive, right? Or when 2 of them are negative and 1 of them is positive, right? Is that correct? So I'm going to first of all do it the way in high school people do this, okay? Which is the following. You make a sign graph, okay? So, whoops. You make a sign graph, so let's make a sign graph here. So let's say I have 0 right here. Well, first of all, as someone suggested, first of all, what I want to know is when is each factor 0? The first factor is x. X is 0 when x is 0, right? When is x plus 2 0? When x is negative 2, x plus 2 is 0. So let's say negative 2 is right here. And let's say positive 3 is right here. So that's when x minus 3 is 0, right? So again, 0, I am on the number line, I am labeling the 0 of each factor. So x, the first factor, x is 0 when x is 0. The second factor, x plus 2 is 0 when x is negative 2. The third factor, x minus 3 is 0 when x is 3. Okay, so I am labeling those on the real number line. Now, notice that these 3 numbers divided the number line into how many subintervals? 4 of them. One is from negative infinity to negative 2. That's one subinterval. Negative 2 to 0. That's another subinterval, 0 to 3, and up after 3. So I have 4 subintervals. So what I want to do is come up with the sign of each factor in these subintervals, okay? So let me start with x. Can someone tell me what are the signs of x in each subinterval? Well, clearly x is negative here, right? X is negative here. Still negative here, right? X is positive here. And positive here, right? Are we okay with that? Okay, let's do the same thing for x. Whoops. For x, my x is coming very funny here. So x minus 3, for example. So x minus 3, where is it positive and where is it negative? Is it negative here? It's negative here. Is it negative between negative 2 and 0? Yeah. In fact, it's negative here as well, right? But it's positive here, right? When x is larger than 3, x minus 3 is larger than 0, right? When x is larger than 3, x minus 3 is positive, right? So it's positive on the right side of 3. Okay, we do the same thing for x plus 2. What can I say about x plus 2? When x is less than negative 2, is that positive or negative? It's negative. When x is larger than negative 2, it's positive. So everybody's okay? Now, I want the product of these three to be what? Positive, right? So let's see, where is the so when x is to the left of negative 2, the product is what? When x is to the left of negative 2, the product of these three factors is what? Negative, 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 right? Which is what? Negative. When x is between negative 2 and 0, what's the product? Positive. When x is between 0 and 3? Negative. When x is to the right of 3? So I want the product to be positive, right? So that implies that x has to be what? Yeah, so either x is between negative 2 and 0, or x is greater than 3. Everybody's okay? And how do I write the answer in interval notation? Interval notation. X could be from negative 2 to 0, parenthesis, you're correct, and then from 3 to infinity. So x is in there. Everybody's okay? Now, there are other ways of doing the same problem, but I'm not going to show you the other ways yet. Other ways depends on the fact that on the left-hand side, the expression that I have, it's a polynomial function, and we will be talking about limits and continuity. Because that function is a continuous function, there is actually an easier way of doing this, okay? But I'm not going to show you that yet. So I'm going to just do it this way for now. Let's look at another one. That was f, right? So let's look at g. Suppose that I have x squared plus x plus 2 larger than 0. How would I do this? Yeah. Can you factor this out? You won't be able to factor this out, I think. Okay. The trick is, you remember the word complete square? Completing square. So, because you cannot factor it out, what you need to do is complete the square in the following way. How would you complete the square? What you need to do on the left-hand side is the following. You need to group together the first two terms, x squared and the x term, and you separate it out from the other term. Everybody's okay? Now, I am going to write this as x squared plus x is larger than negative 2, right? Subtract 2 from both sides. Now on the left hand side, don't factor out, okay? You need to complete this square, which means you need to do the following. I want to write the left hand side as x plus something squared. How do I do it? Well, do the following. Write down x squared plus x. Now you're going to add, look at the coefficient of x. What is that? 1. What is half of that? So the coefficient of x is 1. Half of that is half. And what's the square of that? 1/4. What I'm going to do is I am going to add a 1/4 on both sides, okay? I'm going to add 1/4 on both sides. Again, look at the coefficient of x, take half of that and square it. That's how I'm getting 1/4. Coefficient of x, half of that, square it, okay? And now on the left hand side, what I have is x squared plus 2 times x times a half plus a half squared. On the right hand side, I have what? This is going to be negative 7/4, right? You guys are okay with that? Now, why did I write the left hand side in a weird way? Note that I didn't change anything on the left side, did I? I still have x, right? Because 2.5 cancels out. 1/2 squared is still a 1/4. But why did I do that? Well, I want to apply this formula here. A squared plus 2ab plus b squared. That's the same as a plus b squared. I want to apply that formula here. So take a to be x and b to be half. Then on the left hand side of my inequality, right, don't I have a squared minus 2ab plus b squared? You guys agree with that? A is x, b is half. Okay, so if I take a to be x and if I take b to be half, notice that I exactly get this guy. So I can rewrite this as x plus a half squared larger than negative 7/4, right? Would you agree with that? And without doing anything, I cannot take square root of negative 7/4, right? You guys agree with that? However, is this clear that the left-hand side is always positive? The left-hand side is always positive, right? Because it's a square, which is always greater than, no matter what x is, x plus a half squared is always non-negative, right? For any x, which is definitely bigger than negative 7/4, right? So I can say this works for all x, right? This works for all x. You agree with that? No matter what x you pick, x plus a half squared is always non-negative, which is always bigger than negative 7/4, right? So any x works. Any x works. Everybody's okay, yeah?
What's that symbol you use? The E?
Oh, this symbol means x belongs to. So this means belongs to. Or x is inside of this interval. Okay. You can say x is in this interval or x belongs to this interval. That's the meaning of that E symbol there. It's called epsilon. Everybody's okay with this? All right. All right, so this is probably a good time to review quadratic polynomials, because we just have seen this completing the square trick. So it's a good place to review polynomials, okay? What are polynomials? Well, a polynomial is any expression of the form an x to the n plus an minus 1 x to the n minus 1 plus dot 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 a1 a2 x squared plus a1x plus a0. So if you have any expression like this, it's called a polynomial. What it is that it's you are taking the sum of powers of x multiplied by some constants. So a0, a1, a2, these are called coefficients of the polynomial. Each exponent is a positive integer, okay? Each exponent here is a positive integer. So some examples are like this. If I have just x, that's a polynomial, okay? If I have x squared minus 1, that's a polynomial. If I have 2x cubed minus x squared plus 3x plus 5, that's a polynomial. Again, it's the sum of powers of x where multiplied by certain coefficients, each power is a positive integer, okay? Now, how about this? Is this a polynomial? X cubed minus x plus a 1. It is a polynomial. You might be saying, hey, the x squared is missing, right? You think of this as x cubed plus 0 times x squared minus x plus 1, okay? So this is still a polynomial even if some powers are missing, okay? Everybody realizes what is a polynomial. It's just powers of x. It's a sum where each summand is a constant multiplied by a power of x, where the exponent is an integer, is a positive integer. Everybody's okay? Each summand, except for the last term, right? The last term is a constant term, right? So it's a sum where each summand is a constant multiplied by a power of x, where the exponent is non-negative, okay, if I want to include the constant term. So those are polynomials. If I have a polynomial of the form ax plus b, right, what is that? For example, the polynomial 2x plus 1, x plus 5, these are examples of what we call linear polynomial. Ax plus b. A is a constant, b is a constant, okay? So examples of that would be 2x plus 1, x plus 5, and so on. Everybody's okay with that? If I have a polynomial like this, ax squared plus bx plus c, and here I'm going to say a is not 0, okay? So what would be examples of this? Well, negative x squared plus 1, negative 2x squared plus x plus 5. You know, those would be, let me give you another example. X squared plus 5x minus 2. You know, you can write down lots of polynomials like this. These are called quadratic polynomials. Quadratic polynomials. Everybody's okay with that? If you have a polynomial, what's the degree of the polynomial? Anyone remembers? So suppose that I have a polynomial which is like this: x cubed minus x squared plus 5. What's the degree of this polynomial? Let me call this polynomial p of x, okay? So p of x is x cubed minus x squared plus 5. What's the degree of this p of x? Yeah. So what is the degree? It's the largest exponent that appears in the polynomial, right? The largest exponent that appears in the polynomial. That's the degree of the polynomial. Okay, let me do one more example. Let's say I have q of x, which is 2x to the 5 minus x squared plus 2x plus 7. In this case, the degree of q of x is going to be 5. Okay. When you have a polynomial, the constant term that's called the constant of the constant term of the polynomial. The coefficient of the highest power of x. What's the highest power of x here? Actually 5. The coefficient of that is called what? That's called the leading coefficient. The leading coefficient. And x to the 5 is called what? X to the 5 is called the leading term, okay? Leading term is x to the 5. If you have a polynomial, the leading term is the highest power of x. The leading coefficient is the coefficient of the leading term. And then your constant term means is the term with no x, right? 7. All right. What I'm going to do now, if you have the degree of a polynomial is 3, right? If you have a polynomial with degree 3, that's called a what? It's a cubic polynomial, right? And you can name the polynomials of degree 4, 5, and so on. So we don't need that. What I'm going to do now is concentrate on the quadratic polynomials. Okay. So concentrate on the quadratic polynomials. So a quadratic polynomial looks like what? A quadratic polynomial, I am going to write, consider this equation here. So consider the equation y is ax squared plus bx plus c. This is an equation in two variables, x and y, right? So this equation has a graph. What is the meaning of the graph? Well, look at all the pairs of values of x and y that satisfy the equation, and you plot them, you get a graph, right? So what's the graph? What's the graph of this equation? It's a parabola, right? What happens is that anytime you have a quadratic polynomial like this, you can rewrite that. You can rewrite that in the following way, okay? You can rewrite this as a times x plus h squared plus a k. Sorry, I want to write this guy as negative x minus h squared plus k. Anytime you have a quadratic polynomial, you can rewrite this in this form by using the trick of completing the square. Okay, and I'm going to show you some examples in a second. But if you have a quadratic polynomial, the graph of that is a parabola, and the question is, what is the, everyone knows what the parabola is. It has a vertex, right? And so the graph of this guy, the graph is a parabola with vertex what? With vertex hk. Okay. The reason you want to write the quadratic in the form a times x minus h squared plus k is because if you write it in this form, then you know what's the vertex. Is that making sense? Now I can write the formulas for h and k for you, but we don't really need to remember those formulas. I'll show you how to come up with the values of h and k. Now, when a is positive, the parabola opens what? Upward. If a is negative, the parabola opens downward. Okay. So let's look at an example. Let's say I have let's see. Let's say I have x squared plus x plus 1. Okay. X squared plus x plus 1. And let's say y equals to that. And I want to know the graph of this quadratic polynomial. So in order to draw that, I need to know the vertex, right? So how do I come up with the vertex? Well, I have to complete the square. So the trick again is you are going to group together the x squared and the x term. Okay. And now you look at the coefficient of x. The coefficient of x is half. Sorry, the coefficient of x is 1, right? And you take half of that. You get half. You take the square of that. You get 1/4. So what you do then is you're going to add 1/4. Okay, you're going to add 1/4 inside the parenthesis, but you didn't have 1/4 before, right? So you need to get rid of that 1/4. Now I am going to rewrite this as x squared plus x plus 1/4 and take the negative 1/4 outside. Okay. Now, what do I have here? X squared plus x plus 1. What do I have there? Well, once again, I am going to use the formula that a squared plus 2ab plus b squared, that's the same as a plus b squared. Okay. What if I have a squared minus 2ab plus b squared? Then it will be a minus b squared. So instead of plus 2ab, if I have minus 2ab here, then you get a minus here. Okay. Now, how do I apply that here? Well, what I have here is x squared plus 2 times x times half plus a half squared. That was the reason we added half squared. And negative 1/4 plus a 1 is what? 3/4, right? 1 minus a fourth? 3/4. Okay, so this is what? X plus a half squared plus 3/4. Everybody's okay? Now, it has to be in what form? A times x minus h squared plus k, right? Now, can someone tell me what is a here? 1. What is h? H is negative half, because you see the form is x minus h. So this thing here, if I write it as x minus something, that is x minus a half. So h here is in fact negative half, and k is what? 3/4. K would be negative if I had negative 3/4. Okay? But you have to remember that the sign here is negative, x minus something. Okay? But I have x plus half. So that's like having x minus minus half. So h is negative half. So the vertex is what? Vertex is negative half and 3/4. Everybody's okay? Yeah. Go ahead.
Why did you?
Yeah.
I feel like you lost your middle. Where's your middle x down?
Oh, x squared plus 2x. The whole reason we rewrote this way is so that we can apply this formula, right?
I remember now.
Yeah, complete this square. All right. That's the vertex. So how do you graph? What's the parabola then? Okay, negative half. Let's say half is this much. Okay, and then 3/4. Well, let's say this much is 1/4, okay? So this would be negative half here. And so what is 3/4? Oh, it's positive 3/4, so I go 1, 2, 3. So 3/4 would be right here, okay then? And so that's the vertex. So the vertex is right here. And then the parabola opens upward, right? But I need to know where it intersects the y-axis, because it's going to be opening upward. And where does it intersect the y-axis? How do I come up with that? Yeah, so if you plug in 0 for x and solve for y, what do you get? 1, right? So you know that it intersects. So basically, how do you find the y-intercept, right? How do you find the y-intercept? You plug in x to be 0 and solve for y. So if I do that, so this was my original equation here. So if I let x to be 0, then I get y to be 1. So this is the y-intercept. Y-intercept. So I know that y would be, remember the height is 3/4, so this is where 1 is, right? So my parabola looks like, okay, that was a bad drawing, but you can live with that. So that's the parabola that we get, okay? That's the vertex. Okay. Any questions on that? Yeah.
Can you just go back to the first step in the middle?
Yeah.
What is the reason for
The which step?
the middle x?
Right here or here?
Yeah, right here. Yeah.
Second one?
Yes.
Oh, I am trying to apply this formula here, right? A squared plus 2ab plus b squared is a plus b squared. In order to apply that formula, I am rewriting this expression here as x squared plus 2x half plus half squared. So think of x to be a and half is b. So I am applying this formula by taking a to be x and b to be half. Okay? All right. Any other questions on what we did? No? All right. Let's review factoring out polynomials. Here is an example. Let's say I need to factor x cubed minus 3x squared minus 10x plus 24. Okay, how would I factor this out? Well, this is not an easy one. What you have to do is the following. You have to plug in some values of x and see if you get 0. Okay? So, replace x by 0, plus or minus 1, plus or minus 2, plus or minus 3 until you get 0. So, in this expression, if you plug in 0 for x, you don't get 0, right? If you plug in 1, what do you get? If you plug in 1, what do you get? You want the expression to be equal to 0.
Why don't we equal 0 and 4?
Yeah, but you cannot solve it by using any type of trick here, okay? Yeah. You cannot factor it out by grouping, I think. Let's see. No, you cannot do. Grouping is a trick that works often with cubic polynomials to factor out, but in this case, I don't think it's going to work out. Okay? You have to first of all find root of this that is a value of x which will make this polynomial 0. Okay? So if you plug in 1, I'm pretty sure you don't get 0, right? What if you plug in negative 1? You will not get 0 again. What if you plug in 2 though? What do you get? If you plug in 2, what do you get? You get 8 minus what? 8, you get 0, right? Okay, if you plug in 2, so if x is 2, then you get 2 cubed minus 3 times 2 squared minus 10 times 2 plus 24, and this is equal to 0. Okay. So what we say is that 2 is a root. Okay, so it means that 2 is a root of the polynomial x cubed minus 3x squared minus 10x plus 24. So if you plug in x equals to 2, you get 0. In other words, x equals to 2, that's the x-intercept, right? If you look at the graph of this polynomial, it intersects the x-axis at when x is 2. So x equals to 2 is a root. Now, whenever you have a polynomial and the polynomial has a root, right? Then I can say let me write it down actually, in fact. So let's say, generally, let p of x be a polynomial, okay? A is a root of p of x if p of a is equal to 0. So in the polynomial, if you replace x by a, you get 0. So then a is called a root, okay? So a fact A is a root of P of X if and only if X minus A is a factor of P of X. So once you find the root, you actually know a factor. Okay? Once I find the root of a polynomial, it gives me a factor of that polynomial, namely X minus A. Okay? So in our example, we had the cubic polynomial x cubed minus 3x squared minus 10x plus 24. This is the cubic polynomial that we have. We showed that x equals to 2 is a root. X equals to 2 is a root. Okay? So then I know that x minus 2 is a factor. Remember, my job is to factor this out, right? I found a factor x minus 2. What does it mean? When we say that something is a factor, what does it mean? It means that this polynomial is equal to x minus 2 multiplied by something else, right? Multiplied by something else. So what is that? Something else. How do I find that out? Well, what you have to do is use polynomial division to come up with the other factor. Okay? So you have to divide the polynomial x cubed minus 3x squared minus 10x plus 24. You have to divide that out by x minus 2 by using polynomial division. Okay? Anyone remembers how to do polynomial division? What should I do? Multiply by x squared to match x cubed, right? So what do I get? I get x cubed minus negative 2 times x squared, so that's negative 2x squared, right? Okay, and then I do what? And then add, right? So you change them. So this would become negative and this would become a positive, right? And then you add them. So if you add them, what do you get? X cubed cancels out. And then if you add them, what do you get? This would be negative x squared, right? Because you have negative 3x squared plus 2x squared. Negative 10x plus 24. Alright, now I have to match negative x squared, right? What do I multiply with? Negative x. So I get negative x squared and then positive 2x, right? Positive 2x. Once again, I have to subtract, or as you said, change the signs and add them, right? So if I do that, what do I get? Because you're going to make it negative 2x, right? So if you add them, what do you get? Negative 12x plus 24. And to match negative 12x, multiply by negative 12. So I get negative 12x plus what? 24. The remainder is what? 0. Right? If I subtract now, I get 0. Or if I change the signs and then add them, I get 0. Okay, so that means what? It means that this is what I call the quotient. Okay, this is called the quotient. This is called the quotient. This is called what? Divisor. And what is this guy? That guy is called the dividend, right? So what happens then is that the dividend, which is x cubed minus 3x squared minus 10x plus 24. The dividend is the same as the quotient or the divisor multiplied by the quotient. What was the quotient? X squared minus x minus 12. X squared minus x minus 12. Okay? So we factored out. But I have a quadratic. Can I factor it out anymore?
Yes.
What is that? I think we did that before, right? This would be x minus 4, x plus 3. So we factored it out. Everybody is okay with that? Yeah. Do you have to check your answer? Yeah, if you just multiply out, see if you get the left-hand side if you want to, yeah. I mean, you're not required to do that in the exam, but if you want to check your answer, you could do that. Any questions on what we did so far? Let me just remind you of a couple of formulas here. So one of the formulas that we used here was a plus or minus b squared. That's a squared plus or minus 2ab plus b squared. So if you have plus in the inside on the left hand side, you get a plus 2ab. If you have negative on the left hand side, you get a negative 2ab on the right hand side. There are some another formula that we have seen was what? A minus b times a plus b is equal to a squared minus b squared, right? In order to factor out a squared minus b squared. There are some other formulas which are very useful if you can remember them. One is a cubed minus b cubed. That's the same as a minus b times a squared plus ab plus b squared. Okay? Everybody's okay? Now, if you have, instead of a negative, you have a plus here, then you're going to get a plus here, but then you're going to get a negative here. Okay? In other words, maybe I should write that down. A cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. So you can factor out a cubed minus b cubed or a cubed plus b cubed if you have to. These are, they don't appear all that frequently, but sometimes they do appear and you can apply this. It makes things easier if you remember these formulas. Okay, one last thing that I want to remind you is the following. It's called the not this one, sorry. Quadratic formula. Quadratic formula. So what is that? If I have a quadratic equation, right, ax squared plus bx plus c. So far we factored out, right? But what if you cannot factor out the quadratic? Well, you can apply this formula. Anyone remembers the formula? Yeah. Very good. So this is the quadratic formula for finding roots of quadratic equations. So for example, if I have the equation x squared, say minus x plus 2 equals to 0, then I could say that x is equal to what? The coefficient of x is negative 1, right? So you'll have negative of negative 1, right? It's negative b. plus or minus, it's b squared, right? So it'll be negative 1 squared minus 4 times, what is a? A is the coefficient of x, right? So that's 1. And c is the constant, so that's 2. Divided by what? 2 times a is 1 again. And what do I get? Well, this would be a positive 1 plus or minus. Inside, what do you get? You get 1 minus 8, right? What is that? Divided by 2, which is not a real number. This is a complex number. So in this case, we would say no real solution, right? No real solution. Everybody's okay? All right. I'm going to end here.